So in today's class, I will be talking about the unbalanced transportation problem. As you can see in the slide, there are three plants W, X and Y, and there are three distribution centers A, B and C. W has a supply of 200, X has a supply of 175, Y has a supply of 75. The total of supply is 450. A has a demand of 250, B has a demand of 100, and C has a demand of 150. So the total of demand is 150. Supply is less than demand. So to solve such type of transportation problem, we have to add one dummy plant. The transportation cost of this dummy plant will be taken as 0. And the supply of this dummy plant will be the difference of total supply and total demand, which is 50. Now the demand and supply are equal. This problem has now become like the old problem, and we can solve it by normal transportation algorithm, like the WAM method or least cost method or northwest corner method. So this is the case where there was lack of supply. So we have added one supply source and dummy supply source, and now we have and made the demand and supply equal. So another example I will take. In this example, the supply is more than the demand. The total of supply, take this example, W has a demand of supply of 200 units, X can supply 175 units, Y can supply 225 units. So the total of supply is 600. And A has a demand of 250 units, B has a demand of 100 units, C has a demand of 150 units. The total of demand is 500. So here the demand is less as compared to supply. So we need to add a dummy distribution center whose demand will be the difference of supply and demand, that is 100. After adding this and the transportation cost from to and from different plants to this distribution center will be taken as 0, because this is a dummy. It does not exist in real life. We have introduced this to make this problem solvable by the methods that we have discussed till now. Therefore, now the demand and supply are equal. $600 and $600. Now you can solve this problem, this transportation problem, by the normal methods that we have discussed before. First method is northwest corner rule. Second method is least cost cell method. And the third is Vogel's approximation method. So in case demand is less than supply or supply is less than demand, we have to introduce a dummy source or a dummy destination and make the demand and supply equal. And after making the demand and supply equal, we will apply the normal methods. Next example that I am going to take is that of degeneracy. what is degeneracy in transportation problem. You can see this example on your screen. There are three plants W, sources W, X, and Y, and there are three distribution centers A, B, and C. The transportation costs are written over here. Supply, W can supply 1, X can supply 3 units, Y can supply 4 units. Similarly, A has a demand of 4, B has a demand of 2, and C has a demand of 2 units. Total demand and supply are equal. Now we will calculate the penalties. The row penalty. First row की penalty निकालते हैं. 50 और 30 का difference 20, 90 and 75 का difference 15, 50 and 200 का difference 150, 50 and 90 का difference 40, 30 and 75 का difference 45 होगा, and 50 and 170 का difference 120. Highest penalty is 150. In this, the lowest cost cell is this one, where the transportation cost is 50. Now we allocate the number of units. So we have allocated 2 because the demand is of 2 only. And then we will update the supply. Now new supply, this particular Y, the supply remains only of 2 units. 2 are finished and 2 left. This particular column is no more in our, ये कॉलम हमारी उससे फिनिश हो गया, मतलब ये कॉलम हमारा, इसकी डिमांड कंप्लीट हो गई, तो ये अब हमारे मेथड से बाहर निकल गया. नाउ अगेन वी विल कैलकुलेट द पेनल्टीज. 50 और 30 का डिफरेंस 20, 19 एंड 75 का डिफरेंस 15, 250 और 200 का डिफरेंस 50. कॉलम पेनल्टीज निकालते हैं, यहाँ की 40 ही रहेगी और ये यहाँ की 45. So the highest penalty is this 50. In this row we will find the cell with the lowest cost. Now we have this 200 as the lowest cost. We will see the demand and supply. 2 is the demand and 2 is the supply. So we will allocate 2 units. As soon as we allocate 2 units in this cell, the demand for this particular column is over. Also, the supply of this row is also over. So these two things eliminated simultaneously. When a row and column eliminates simultaneously, this causes degeneracy. Now only 2 cells are left. Only 1 column is left. 2 cells of 1 column are left. So we will see the demand and supply and complete the. So one unit will be supplied here and 3 units will be supplied here. So as you can see here, now I will just remove the yellow color. as soon as we remove, after the allocation is complete, we see number of allocations is equal to 4 here. The cells in which allocation is there, 1, 2, 3, and 4. And number of columns is equal to 3. Number of rows is equal to 3. So what is the total of number of rows and number of columns? It is 6. And also we see that what is m, number of rows is m. इसको हम m से डिनोट करते हैं, इसको हम n से डिनोट करते हैं, और ये हमारा है m प्लस so it will be 5. So अगर हमारी नंबर ऑफ एलोकेशन m प्लस n माइनस 1 से कम होते हैं, दिस कॉजेज डीजेनरेसी. इस प्रॉब्लम में क्या है? डीजेनरेसी. नंबर ऑफ एलोकेशंस, ये हमारा नंबर ऑफ एलोकेशंस है. Number of allocations are less than m plus n minus 1. m plus n minus 1 आया 5 और number of allocations थे 4. तो ये this is a case of degeneracy. इसका degeneracy का प्रॉब्लम क्या है कि इसमें हम ऑप्टिमम सॉल्यूशन निकालने के लिए मोदी मेथड डायरेक्टली अप्लाई नहीं कर सकते. मोदी मेथड is a method to get the optimum solution from the initial solution. ये initial solution के 3 methods हैं जो हमने देखे, और मोदी मेथड लगा सकते हैं. मोदी मेथड का फुल फॉर्म है मॉडिफाइड डिस्ट्रीब्यूशन मेथड. तो मोदी मेथड लगाते हैं हम ऑप्टिमम सॉल्यूशन निकालने के लिए. लेकिन अगर नंबर ऑफ एलोकेशंस जो हैं m प्लस n माइनस 1 से कम होते हैं तो हम मोदी मेथड डायरेक्टली नहीं लगा सकते. So this is a case of degeneracy. So I think unbalanced transportation problem is clear to you, as well as degeneracy that occurs in transportation problems. Thank you.